So let's get rid of the inclined surface, and let's imagine that this is a horizontal surface. Well, not the best drawing. So let's try to do better. So here is a horizontal surface, and on this surface, let's place two objects. This one is of mass, let's say m star, and there's one over here of mass, 3m star, 3 times the mass of the other. Let's attach these two by a string, and let's imagine that we pull this object with a force whose value is F naught. It's a constant force of magnitude F naught to the right. Let's leave it at that. So let's try to understand the dynamics of the system. So MA equals the sum of the forces, or MA equals the net force F, applies to every object in the system. And so we could do a free body diagram to identify how to apply this to every object of mass. So we could do it with, so let's make a free body diagram for this object. And therefore here's m star. We know that there's a force of gravity acting downward, so we have m star g downward. There's a normal force acting upwards. Let's call it Fn1 for the normal force on this object. Then we have a force this way, which is an unknown tension, and that's it. There's nothing else acting on that object. So that's the end of the free body diagram for that one. For this one, we have a force of gravity, which is 3 m star g acting downward. We have an F normal 2, let's call it, acting on that one upwards. We can see that there's a tension force here, which is to the left, because the string is pulling it that way, and that tension force is the same as this tension force because it's one string with one tension. And there's the force F naught to the right. Of course, the T is unknown. So is the Fn1 and the Fn2. F naught is known and m star is known. So what does MA equals F tell us? Well, so we have vertical and horizontal components. So the vertical component on this object tells us that because the object is not accelerating in the vertical direction, we have 0 is equal to Fn1 minus m star g. And of course, that gives us Fn1 equals m star g. And the other equation tells us that m star a, so it's important to notice that there's only one acceleration here because there's a string connecting the two objects. So whatever the acceleration is on one, which has to be to the right, must also be the acceleration of this object. So we have m star a is equal to, in this case, there's only a tension force. And so that equation has two unknowns, the acceleration in the horizontal direction and the tension force. So this is, we have one quantity solved here. And so the information here must come from the other equations. So in the vertical direction for this object, again, no acceleration. So we have Fn2 minus 3 m star g. And that gives us Fn2 is equal to 3 m star g. And so we know the two normal forces acting on these objects. And the horizontal component of MA equals F on this object says that 3m star times the same unknown acceleration A is equal to the sum of the forces, which is F naught Right, we came in with a tension, so to the right is positive, and so we need this one to be positive, but the tension force comes in as negative here. So we have a negative T here, and so we see that we have two equations and two unknowns. We could simply add these two equations and get an equation which says that the sum of the masses times the acceleration A is equal to the net external force F naught, where the tension force is really an internal force between the two objects. So what I'm saying is, let's add these two equations. Let's add this one to this one, and so we have m star A plus 3m star A, that's 4m star A, and the right-hand side is t minus t plus F naught, that's equal to F naught. And so we can get the acceleration of the system as F naught over 4m star. And so we know what the acceleration of the system is, and of course now we can plug it in to get the tension, and the most straightforward way is to plug it into this and get A equals T over m star, which is F naught. Sorry, what am I doing here? I got the acceleration, I want the tension. The tension is m star times A, and so my pencil is no good. So it's m star times this, which is F naught over 4 m star, which is F naught over 4.